Yesterday we saw some examples, MapReduce examples, code co-occurrence and the inverted index and the average length, and we saw some MapReduce programs, and also we discussed about this combiner concept. So if you want to improve the performance, we will use the combiner. Okay. Then I think yesterday we saw partition also. So if you want to separate the MapReduce output, and if you want to pass to the particular reducer, we will use this partitioner. So today we will see some practical example how we can partition the data. So simple. We will let the same mapper. It will emit the one letter letter and the output key. So for each word, it is trying to emit the first letter as a key and the full word as a value. And reducer, same thing. Reducer we will implement reducer. Just we will return the values, and okay, full value only we are returning. We are not returning key. That single letter we are not returning. And value we can return null also. Null also we can return. For that we need to maintain the null writable. So partitioner, what I am doing means I am extending the partitioner class, and I need to override the get partition method. In this method we have the input what is the key and what is the value and number of reducers. Okay, here this logic for the separating the values MapReduce output, and here we are passing to two different reducers. So if key is starting with AEIOU, then the data it needs to go to the first reducer. Other than that AEIOU, the data it will be moved to the second reducer. We will run and we will see how it will be. Here just we are doing means, suppose if you have the multiple reducer, we need to implement the logic for separating the mapper input, mapper keys. We need to partition the keys, and we need to pass the input as the different reducers. That logic only we will implement in this get partition method. Change the name. Jar file partitioner.jar, and we will change the driver name. Input data will give any file, will give companies. I think, okay, now we'll get error. We need to set the number of MapReduce, otherwise we'll get the error. Why means we are trying to, I will tell you. I think the job is failed. Why means so illegal partition for one. So in my partition, I implemented the logic for the partitioning as a two reducers, and I'm trying to move the mapper output data for the two reducers. But currently here I have only one reducer. That's why only it throws the error. So for that, we need to set the number of map reducers equal to 2. So by default, we'll get only one reducer. So that's why only here we need to set the reducer task equal to 2. I think if you observe here, I think same error will get illegal partitions for one. So we have only one reducer, but we are trying to insert the data into, we need to try to pass the data into second reducer. That's why only we are getting error. So now same code I changed it, only I'm setting the number of MapReduce tasks equal to 2. Then we'll check it. I hope it is executing. Now if you check here, I think we got the two reducers. So then we'll get the two outputs. Two output files we'll get. We'll check it. Custom partitioner output 1. So now we got the two. We have the two reducers for current job. So that's why we got two output files. So first output file, if you check it, all the words, it will start with AEIOU only. If you check it, it will start with AEIOU. And if you go through second partitioner, so all the words except AEIOU will get the output. So like this, we can separate the mapper output to the different reducers. We can like this we can. So here like this, suppose if you have the different, suppose if I have the 10 years data, so I have the 10 reducers. So if I want to pass the 2010 year data to the first reducer, 2011 year data, you need to pass the second reducer. Like that, if you want to separate the things, so we can customize the partitioner class and we can do it. So mainly why? Because one advantage of this partitioner means, so we can balance the data. So suppose if we have the large amount of data, so we have the only one reducer or two reducer. So all the data, suppose we have the large amount of data, so all the data will be we will pass as an input for the only one or two reducers. Instead of that, if you have the large data, so if you suppose if you have the 10 or 10 reducers, if you want to, instead of so passing the full data to the one reducer, if you balance, so by using this partitioner, we can balance the we can distribute the data to the different reducer, and we can balance the reducer input. So that will be one advantage of this partitioner. So whenever if you want, so then only we will go through the custom partition. Okay, this is about the custom partitioner. So through combiner we can improve the I think yesterday we discussed about the combiner. So through combiner we can improve the performance. So it will be run on each node as a reducer. So for improving the performance, we will use the combiner. Partitioner, by using partitioner, we can implement the our custom by using custom partitioner. We can implement our own logic for the partitioning the mapper output and passing the different reducers. So we can customize the partitioner. So
can partition be customized dynamically?
No. We need to implement before going to dynamically we can do. So whenever we want, so we want to partitioner, we need to implement the partitioner logic, and we need to create the jar, and we need to I think dynamically we can do. We need to write the separate. If you want to change the logic, we need to change the partitioner class, and we need to implement. Dynamically, I think we can partition.
Okay.
Okay, then we will go through one more example, searching. So I will. I'm going to see one more example. In this example, I have the input data. I want to search for the particular word. So that word I need to pass through command line. How we can do it? This is the way. So here what I'm doing means, in mapper class, I'm searching for the particular keyword. So if this keyword is there means, then only I'm trying to emit the trying to emit the data from the mapper. So here what is the search word, where we will read the search word, this keyword or searching word. So this word we will read from the command line. So this terminal, while running the program, we will pass the this search word. So this word we will read. We can read from the mapper or reducer class, and we can write any condition kind of things, and we can use this this parameter. We will see how we can use this parameter. Just for if you want to this we are setting the here by using the tool runner, we are setting the MapReduce related settings. So like these settings, we can pass the parameters also. If you want to pass the time while running the while running the program, MapReduce program, if you want to pass any parameters, we can pass like this, and we can use those parameters in mapper or reducer. So if you want to use, so like this, we need to use the context dot get configuration dot get search dot what. Then you will get the whatever we are setting through command line option, we can access that one. Okay, we will create the jar file and we'll try to run it. Same file we'll use, but we'll change the jar name. Jar, and we will change the driver class. So instead of using this property, we will use the, we'll pass the search parameter. So through here I will pass this parameter search dot word. So here in MapReduce I'm reading, and I'm emptying only if I have this keyword. I think here I'm passing the the. So if I having the word with the, then only it will match and it will return the key. Otherwise it won't return any data. Mapper won't return any data. So reducer we will do same thing. We will do some operation. Everything is same. Driver and everything same. So we will configure mapper and reducer. Everything is same. Just this program for just understanding how we can pass the parameters and how we can read it in the MapReduce program in either in mapper or reducer. For that understanding only, I'm executing this job. So once completed, we'll check it. I think completed. Okay. Then we'll go through output. So here only this word the word it is occurred in 8406 times. So in that particular file, commodity file, this word is 8406 times is there. Like that, if you want to search any keyword by passing the as a parameter, so we can do it. We can instead of changing in the code, we can directly while running itself we can change the here itself. If you want to search for the other one, simply here we can change the other one and we can simply run the same program. Then, till now in mapper and reducer class we saw only one method called map method. So other than that we have the two more methods, setup and cleanup method. So if we go through here, till now in mapper or reducer, in mapper we saw only map method, in reducer we saw only reducer method, but we have the like setup and cleanup method also there. So these are the two other methods in the either mapper or reducer class. Setup method, cleanup method, optional. But we must implement the either mapper, we must override the either map or reducer method. Setup and cleanup method are optional method. Suppose for I think if you submit the job, we will get the different map tasks. So when this setup method will execute, it means while starting the map task, that time only one time only it will call setup method. So mostly we will use the setup method for the kind of configurations or any configuration related things if you want to do, then we will use the setup method. So it will call only initial starting of the map task, only one time only it will call. This either map or reducer method, it will call for each line. Each line it will be called. Suppose if you, for particular input split having the 10,000 lines, so for each line this mapper or reducer method will call. And corresponding key value, it will process some, it will do some kind of processing in parsing kind of things we will do in the mapper, and aggregation kind of things we will do in the reducer. So in mapper, finally map method, it will emit the output as a key value page. So if you want, we can skip the map method output also. So here if you check it, only we are not emitting, or we are not pushing the all the output from mapper. So here we are only based on particular condition only we are emitting the key value page. If you want, we can do that one also. If you want to skip the output key value from the mapper, we can do it that one also. Okay, one more method is the cleanup. Cleanup method will call end of the map task. So mostly what kind of operations we'll do in cleanup means, cleanup we will do kind of any closing. If you open any kind of file openings, or if you want to close any kind of data source closing or anything, any kind of closings, if you want to do, we can do it in the cleanup operations. So it will be called only one time at end of the either map task or reducer task. So this is about the setup and the cleanup method. This is the like same like map. We will have the two more other methods. One minute, I have the question from the Shekhar. I think your question is good question, Shekhar. I think Shekhar question is map return type is void, so it won't return any value to write. How is the map method return the value? So basically this method returning means it won't return any values. Simply it will do means context.write means it will store the key value page into some location. So that kind of things only it will do, kind of writing the data to the some files, like that it will do context of write. It won't return any value to the other methods. That's why only we are using void. So I think most of the things, if you observe here, we are not returning the values. Here we are trying to emit the key value page. Emitting means these key value page will return to some location. I think some local till we are moving to reducer, it will be stored into some local location. Then once all the mapper task is completed, then this key value page will move to the reducer for passing the reducer operations. So we'll move, once it is moved to the reducer, all the whatever the temporarily we stored in local, so that data it will be deleted. So here we are not returning any data. So simply we'll key value paste will copy to some local location. Framework will do it, that one. So I think okay sir. Okay, good. I think you got the answer, I think. Okay, good. Okay, then we will go through this setup and cleanup method. So you can go through this material. You will get the more information about this setup and the cleanup method. Okay, next we have the one concept called distributed cache. So this concept I will give the brief idea. While discussing about the joins, you will get the more details about this distributed cache. So this distributed cache, why will use means, so till now we are reading the data from the only single path. So if I will pass the input path and I will read the data and I will perform any operations and I will storing into some output path. So now if I have the data in two paths, so in that cases how I can get the data from the two sources. So we have the one concept called distributed cache, but here when we will use the distributed cache means if I have the one large file and one small file, so if you want to combine these two combine the data from these two files, then I will use the distributed cache. So distributed cache means I will by using distributed cache I can store the small files in the memory, and in mapper or reducer I can read that whatever we store into memory. So that data we can read it and we can use it in the either mapper and reducer we can use it. So while doing, I think mostly this distributed cache we will using the map side join. So how we can join the two data sets or two different data, how we can join in mapper. So while discussing in that one, I think we will get the full idea about this distributed cache. Main thing in distributed cache is means if you have the one large file and one small file, if you want to combine these two files, a small file will put into memory and large file we will read normally. How we can pass the input path, we'll pass it, and whatever we stored in memory we will read it in the this mapper and reducer. We will combine the both data, large file data and small file data we can combine. So this is the distributed cache. So while discussing about the map side join, we will go through more details. Here we can store the any distributed cache facility provide caching of the files, any text file, jar file. We can store the any kind of files, we can store it. Like this we can store any. Next class we will see more details. While doing MapReduce jobs, I will give more details about distributed cache. I will give more details. So that is about the custom combiner and partitioner and the setup and the cleanup method. Now we'll see what is custom keys and what is custom input format. I think I already explained about the custom partitioner. Now we'll go through the custom keys and what is the custom input format. I think in driver class, if we observe, till now we are using the only text input format. Like that, we'll have the different input format. I will tell once I explain the custom keys, then I will explain the input format. So next, coming to this keys and values. So here till now we are using only predefined, already whatever they define the keys. Those things only we are using. We are using text. We are using int writable. Like that, we will have the long writable, float writable. Like that, we'll have some predefined writables. So instead of that one, if you want to write our custom writable, instead of using text, if you want to write any custom writable dot class. How we can do it, we will see. So why means maybe if you want, instead of using this string and integer, if you want to use any object as a key, then how we can do it, what are the steps we need to do, we'll see. So I think MapReduce, if you want to use any key value pairs, till now we use only predefined data types like the writables, text or interwritable like this. Why we are using writable means, writable we are using for the serialization. So Hadoop will use the own serialization. Here I think, here I will tell one more point. Actually, we already, I think you are having knowledge about Java. I think you already having idea about the serialization, Java serialization. So I think we already have serialization in Java. So Java serialization, I think by using, I think you already have knowledge about the Java serialization. So in Hadoop we won't use that serialization. So why means Hadoop serialization will be fast and compact compared to Java serialization. Why means suppose I think in Java, I think everything we will do with, I think, object input stream and I think object output stream. In Java we will serialize with, I think, object input stream and object output stream. So here we will do the, in Hadoop we will do the serialization with the writables. So what is the advantage then Java serialization means? In Hadoop serialization we will specify the what is the data type. So suppose if it is string means we will use the text like that. If it is the data type is the integer, we will use the integer int writable kind of type specification will be there in the this writables in Hadoop serialization. But in Java serialization we won't have that kind of things. So internally we need to maintain the this type information. Basically in Java serialization we will implement by using the object input stream or object output stream. So we don't have the information about the what kind of data type we are going to serialize. We need to maintain internally in the object. So that will consume some space, and for getting the type information, maybe it will be a little bit slow compared to this Hadoop writable. So in this Hadoop writable, in Hadoop serialization, this writables itself, while creating the object, it will specify the what kind of data type. So if it is the string means we will create the text writable. Text will create text. If it is integer kind of data will create the int writable kind of thing will be there. So that's why Hadoop serialization will be fast and compact than the Java serialization. So I think if you have the idea about the Java serialization, I think you will get my point. So if you want to provide the serialization in the Hadoop, we need to implement the writable interface for the custom values, and same time we need to implement the writable comparable. So if you want to define any data type, any your data type as a key, then we must implement the writable comparable interface. So internally this writable comparable will extend the writable interface. So simply if you implement this writable comparable, we can use it as a key. So in MapReduce we are using the keys. So we can use like a key, we can use it. So if you want to use any class or any key in the MapReduce program, we must implement the writable comparable. So why we are using comparable means in this writable comparable we have one method compare to. So I think if you want to if you want to I think in reducer we need framework needs to do the sorting in the reducer. So that's why only we need to implement this compare to method for comparing the objects. We need to implement this one method called compare to. I will explain. I will tell this method compare to method. I will show that method. So this is the example. I will give one real example before going to that one. This is the how we can do the this custom. We can implement custom writable. We can implement writable, or we can implement the writable comparable. So this if you implement the writable, then we'll have the main two methods. One is the read fields and one is the write fields. Serialization, I think one end we will use the write method and other end we will use the read fields. One side if you are passing through network, one end we need to write the we will use the write field. Another end while reading the another side we need to call the read fields. So that's why we need to implement we need to override the two methods, read fields and the write method we need to implement. These are the two methods in the writable, read fields and write. So then coming to, if you want to use any key as a custom keys, then we need to implement the writable comparable. So in this, apart from the read fields and write method, we have one more method called compare to. So why we are using compare to means, if we want to sort the keys, then we need to implement the which key we need to use for the sorting. So for which key we need to compare. So that logic we will implement in the compare to method. I think if you, I think I think in Java, I think you already idea about the comparable and comparator. So presently we are using the comparable. So next we will see the where we will use the comparator also we will see. So for natural ordering we will use the comparable. So that's why only by default framework will do the sorting on the key. So that is the natural order. So for that order we will use the comparable. So if you go through this one, you will get the more data about the more description about the each field. Why we are using read fields, why we use the write, why we use the read fields, and what is this compare to. I think we will get the more details here. We'll have the more points. So you can go through this one. We will see the how the custom key will be there. I will see. So we will have the one project called word count using custom key. So first I will see, I will show this one how we can customize. Then I will tell one real example. So everything is same: mapper, reducer, driver. Everything is same. In mapper, what I'm going to do means, so I created one key, custom word key. So this key I'm going to use in the mapper. So previously in mapper, in word count mapper, we use long writable, text iterable. So instead of text, here I'm using the one I created one custom word key. So this key I'm using. So while returning also, I'm instead of while emitting the values, so I'm using only instead of text I'm using this custom word key. So how we implemented with the custom word key. So I implemented this interface writable comparable. So here I'm implementing I'm overriding two methods, read fields. Just I am using reading the fields from the data input, and I'm trying to write into output. So these two methods, while these two methods will call while serialization and deserialization, these two methods will call. While serializing, it will use write, and while deserializing, it will call the read fields. And we are using one, we are overriding one more method, compare to. For the sorting purpose, we need to override this method. Then other two methods are get and setter methods. So like this, we need to implement the custom key. So here simply what I'm doing is, instead of text, simply I'm using the internally, I'm using the only one member, one variable only I'm using word. So just I'm trying to simply previously what we did text, same thing we are doing here, but instead of using the text method, we are using the this one. We are using the custom word. Simply internally we are using only text only, text data type only, but instead of using in customize, what we are doing means, instead of providing the text, we are using the custom word key. So like this, we can implement the custom word key and we can use in the mapper class. So I will explain one real example where we can use and how we can do it. I will tell you. Okay, now I have some data like this. So employee ID, some date of birth and F name, L name, like this. I have some input data. So now I am going to create one key with the at a time. Instead of now I want to emit the key as a employee ID, department number, and F name and L name. So in that cases, we need to emitting as a 4 keys, it will be difficult. Instead of that, what I am doing means, I am creating the one custom key. This is one more project using custom key. So in this, I created one custom word key. So here what I am doing means, I created three variables: employee ID, department ID, full name. So now I want to, for each key, I want to emit these values: employee ID, department ID, only full name from the data, from incoming data. So I have the data like this. I have the lot of fields. In that, I want to return only a few fields as a key. Then how we can do means, we need to write the one custom key. So in this key, I implemented the writable comparable. So this is the in this I'm using three fields. So this is normal constructor. Here in read fields, I need to read the every field. Here writable, I need to write the every field. Similar like that. Here, in compare to what we are doing means, I need to do sorting based on only employee ID. I don't want sorting on the department and full name. So just I want to do the sorting on the employee ID in natural order. Then we need to write the condition, compare condition only on the this employee ID. Remaining methods are the getters and setter methods. Finally, if you want to get the this data as a string, I am appending all the employee ID, department, and full name. So like this, we need to implement the custom word key. So what I am doing in mapper means, mapper simply I am using custom word key. Instead of returning the single value, I am returning the three values. I am combining these three values. So this constructor, I am passing the three values: in index 0, index 2, index 3. What are these values? Index 0, index 3, index 3. So our input data is like this, the data it will be there. So what I am doing means, so for each line we will get this string, this full string will get. So this map method, it will get the each line as a input. So this value we are trying to split using the space, then we will get the I think seven values will be get into this array. So these things we are using by using index. Array of 0 means we will get the employee ID. So array of 0 means we will get the employee ID. Array of 6 means we will get the department ID. Array of 2, 3 we will get as a F name and L name. So these things. So for first employee ID we got the index of 0. For department ID we got the array index of 6. For full name we are I'm concatenating F name and L name. So finally I created the one custom key object. So this object I'm passing I'm passing. So value we are not returning anything, simply null writable. So we won't return any value. So simply we are writing the keys. So here if you observe here I'm not going to use reducer. If you want we can use the reducer here, but simply without reducer, just I want to see how the map only job will be there. So for that also I created only mapper class. If you want we can create the reducer, and simply whatever we are returning from this key values, same thing we will return from the reducer. So here I think we don't need the reducer, simply we are parsing, and we are here we don't want to do any aggregation delay kind of operation. Simply whatever the input is there, so just I want to fetch some data from that input data, and I want to write to HDFS. We will see that one how we can. Okay, we will run the this example, then you will get the more clarity on this custom key. So I already created one sample file in the HDFS. This name is employee_custom_key.txt. So this is the input what we are talking. So here each data is separated by the space. First one is the employee ID, second one is DOB, next one is the F name, L name, gender, hire date, and the department ID. So this is the input data. So I created the custom key for fetching the these things. So instead of using the text or iterable, I created one custom key. So that custom key will have the different values: employee ID, department ID, and the name of the employee. It will be there. So we'll run it and we'll see. Okay, we will delete. I think this folder already exists. I think we'll delete it. I think you have. I think you remember this command. If you want to delete any folder from the HDFS, we need to use the Hadoop space fs space rmr. Why we need to use the rm? R means for recursive. If you want to delete the folders, we need to use the R. If you want to delete the file, simply rm is enough. I think last while discussing about Hadoop, we already see we already discussed about this command also, remove command also we discussed. Okay, I think we got the error because of the that folder is already exists. That's why only I deleted that folder and we will try to again. We can check the either status we can check in the job tracker, or we can check it in the console also. We can check. Okay, I think completed. Here if we check it, reducer input records are 7 and output records are 7. So this is the output. So finally how we are printing the output means we are printing like this. We are printing the data with the tab separator. So that's why only we got the data like this. First one is employee ID, second one is department ID, second one is next one is the full name. Full name we are concatenating the both the values. So here we are printing the employee ID, department ID and full name. Full name we are concatenating both the first name and last name. So like this we can implement the custom keys. So instead of emitting only text or iterable, like this we can create our own keys and we can emit the multiple values at a time. We can emit. So this is about the custom key. I think I hope you understand. This is one example how we can implement the custom word key. Okay, good. Here, if you observe this one, this data is sorted by only using the employee ID only. 1, 2, 3, 4. Through employee ID only it is sorted. It won't sorted based on the department ID or first name or L name. So it only sorted through this one. This is the natural ordering. We will only sort this one. We will only sort the key value. This is the natural ordering. Instead of that one, instead of this sorting, if you want to if you want to sort based on values also, if you want to sort based on key and values also, if you want to sort, then that kind of sorting we'll call it as a secondary sorting. Instead of sorting based on the keys, if you want to sort based on the values also, if you want to do we can do that concept. We'll call it as a secondary sorting. Next class, tomorrow class, I will tell you what is secondary sorting and how we can do it. So for that we need to implement the one interface called Writable Comparator. Instead of comparable, we need to implement the comparator. I think in Java, if you have the difference about the comparable and comparator, then I think here also same way will be there. Comparable we'll use for the natural ordering. Comparator will use for the, if you want to sort, if you want to compare two different objects, then we will go for the comparator. So same thing we will use in the comparator, we will use in the secondary sorting. We'll see while discussing about the secondary sorting. We are defining the one input format as a text input format. So basically why we are defining this text input format? So input we will have a input split. So from that from that basically we'll have the data. Input data is like a one file. So that file we are splitting as a input splits. So each input split will have the some amount of data. So say suppose if you have the 10,000 lines, so these 10,000 each line we need to convert as a key value. Why means for map method we want only key value. We are not passing as a single line. We are passing as a key value page. Who will convert this one, this single line to this one key value page? That will take care by the record reader. So in this case, text input format, already they implemented the record reader for the text. So similar like that, if you want to suppose if you have the input as a Excel file, so how we can read that file, how we can convert as a key value. So if you want to do like that, we need to implement our own custom input format. So instead of using the already existing input format, if you want to create one your own input format, we need to create our own custom input format. So before going to that one, we'll see how the this input format will be there. So generally we'll have the one input file. So this input file will be split as a input splits based on the input split size. So each input split will have the some data, maybe 10,000 lines or 20,000 lines. It will be depend on the split size. So from that, this record reader will come into picture. This record reader keep on. I think if you observe this circle, it will be iterate. So for each line, so it will read the each line and it will convert. It will call the map method, and for each map method, it will pass the each line as a key value pair. It will pass to the map method. So like that, this record reader will read the each line and it will convert as a key value and it will pass to the map method in mapper. So this map method will read each key value and it will perform some parsing operations and it will emit the intermediate output. So this intermediate output will be stored into local disk. So this is about the input format. So if you want to customize input format, we need to extend the file input format. Then we need to internally we need to implement the record reader for how we can this one how we can read that input data, how we need to convert as a key value pair. That logic we need to implement in the record reader. I think if you go through this thing, I think we'll get more details. Record reader, what it will do. Whatever I explained, I think those points will be there here also. So this is about the input format. I think before going to, I think previously also I discussed, I think I explained. So we have the different input formats, text input format, and also key value text input format, n-line input format, db input format. Like this, we already having some input formats. If you want, we can use that one. Otherwise, if you want to write your own custom input format, we need to write our own custom input class, a custom input class we need to implement. So we already have this using custom input format project in our thing. So we need to import that one by using the import. We already using custom input format. You can import this project into Eclipse. So here what we are doing means in custom input format, wiki mapper. So everything mapper and reducer is same. Mapper. I think we don't. If we want, we can create reducer also. In this example, we don't have the reducer. We have only mapper. So if you want to write custom input format, we need to write the one input format class. Wiki, here we are writing wiki project input format, and we are extending the file input format. So if you want to write your own custom input format, we need to implement, we need to extend this input format, and internally we need to implement one method called create record reader. Internally, this create record reader, we need to implement our own record reader, that is the wiki record reader. So here we will have the one main method, important method is the next key value. This key value, this method only, we need to write our own logic. How we can read that input split data, and how we can convert as a key value pairs. That logic we will write into this one. So once if it is convert as a key value pairs, we will return as a, whether it is success, then we'll return true. Otherwise we'll return the false. So then only, so if the data is there, then it will return true. Then it will try to read the next. It will read. So simply this input format we will specify in the this one. Driver class will specify the what is the input format. Wiki project input format. So this input format will specify in the driver class. Like this, we can implement our own input format. So once all the things MapReduce classes over, I will explain how we can read the Excel file. I will tell one example by using this custom input format, how we can read the Excel file. How for reading the Excel file, how we can read our own input format. I will explain. Okay, this is a basic idea about how we'll create the input format and how we can create the record reader. So tomorrow class I will run this program, and I will show I will run this custom input format, and I will show how the output will be there, how we can create custom input format. We will see. I think this is about the custom key and the custom input format. I hope you understand. Tomorrow we'll go through the other concept. I think only remaining things are we'll have the joins. So map side join and reducer side join will be there. So tomorrow we'll go through that one, those joins, and any other concepts is there, we'll go through that one. I think that's all for today. Thank you all.